In this lesson, we're going to be looking at the law of cosines. And again, we're looking at ways that we can solve oblique triangles. That is a triangle that doesn't necessarily have a right angle in it. Law of cosines can be used for a right triangle, but our focus at this point would be those that don't include a right angle. So the law of cosines, which is included on your formula sheet, looks like this. A squared equals b squared plus c squared minus 2bc cosine A. Okay, and so what's A, B, or C is really arbitrary. So we can write this formula in terms of B or C. So for instance, I could say that B squared equals A squared plus C squared minus 2AC cosine B. Or C squared equals A squared plus B squared minus 2AB cosine C. Okay, so on the formula sheet, you might see only one form of this law of cosines formula written, but you should be able to write it in terms of any side and angle. Okay, so let's see how we're going to apply the law of cosines. In this example, we have two sides given, sides A and C, and we have angle B, which would be between those two sides. So we're going to use the law of cosines to help us solve this triangle. We'll start with b squared equals a squared plus c squared minus 2ac cosine b. Or b squared equals 2 squared plus 1 squared minus 2 times 1 cosine 10 degrees. Okay, we can put all of that on our calculator. And we get 1.06, or if I take the square root of that, I get 1.02, or approximately 1.03. Okay, so we'll say B is approximately 1.03 for right now. Okay, of course, on our calculator, we're going to store that value for B because when we do additional calculations, we don't want to have any round off error. So I just hit the store key, alpha, and then I chose one of the alphabet. Of course, I chose B because that makes sense, and enter. And that way, whenever we pull up variable B, until we change it, it's going to give us the value 1.0299364. All right, now that I have that, I'm going to use the law of sines because now I have a side and I have the angle that's opposite that side. So that allows me to use the law of sines. I have to have the pair in order to use the law of sines. That is a side and the opposite angle. So I can say sine A over the side A, the length of side A, which is 2, is equal to sine B, or sine 10 degrees, over 1.03, and I'll just put ... to remind myself that I've got all of that in the calculator. So we get sine A equals 2 times sine of 10 degrees over 1.03 ... Okay, and so we get On the calculator, 2 sine 10 divided by alpha b. So I get sine A is equal to approximately 0.3372. And of course, I want to know what A is, so I'll use sine inverse. So second sine inverse, second answer, I get 19.7 approximately. So A equals 19.7 degrees. Okay? And then from there, I can figure out C that goes with that. C would have to be 180 degrees minus this 19.7 number, okay, and minus 10. All right, if I do that on the calculator, and let me store that A value. So I'll store this as alpha A. Okay, so we got 180 minus alpha A minus 10. I get 150.3. Okay. All right. So we need to look and compare the angle value to the length of the side. In this particular scenario, our smallest side is actually C. But with the angles that we've come up with, we get the largest angle opposite that side. And we know that that can't be true. So this can't be a solution. Okay, this doesn't work. Okay? But remember, with the law of sines, often we have two possibilities. So do we have another possibility? Well, if we look in quadrant 2 at the angle that has a reference of 19.7 degrees, okay, which is going to be 180 minus the 19.7 number. So 180 minus alpha A. Okay, we get 160.29. Okay, so we're going to call that A prime. All right. And from there, of course, we can get C prime. C prime is going to be 180 degrees minus this 160.29 degrees number minus 10. So 180 minus what we just calculated here. So I'll do second answer minus 10. And we get 9.7 degrees. Okay. So when we compare now, our smallest side is C, and the smallest angle, let me just summarize our solutions. We found side B was approximately 1.03 units, and we found angle A prime is 160.29 degrees, and C prime would be 9.7 degrees. So our smallest angle is opposite the smallest side. The largest angle, the 160.29 degrees, is opposite our largest side, and that will form a triangle for us. So there was only one solution for this problem. All right, let's look at another case with the law of cosines, but this time we have just three sides, but we can still use the law of cosines to help us solve this. And it doesn't matter which of the sides we solve for first, so I'll just write this as a squared equals b squared plus c squared minus 2bc cosine a. Okay, and what we're really trying to solve for here is our angle A. That's what we want to solve for. So I'll plug in my values. I've got 4 squared equals 3 squared plus 6 squared minus 2 times 4. I'm sorry, 2 times 3 times 6 times cosine A. Okay, I'm going to pull everything to the other side as much as possible. So I've got 4 squared minus 3 squared minus 6 squared. Okay, and that's going to be equal to negative 36 cosine A. All right, and so I can divide both sides by negative 36. And so I'm going to get cosine A is equal to this 4 squared minus 3 squared minus 6 squared all over negative 36. So I'll do that on the calculator real quickly. Okay, I got 0.805555. All right. I need to know what A is, so I'm going to do cosine inverse. And so we get 36.3 for angle A. So I'm going to store alpha A, 36.3 degrees approximately. Okay, so now I have an angle and the opposite side, so I can use the law of sines to help me find additional angles. Okay, so I'm going to do sine B over the length of side B. Okay, and we've got sine A, which is 36.3 over the length of side A, which is 4. Okay, or we get sine B equals 3 sine 36.3 degrees all over 4. Okay, when I do that, I get sine B is equal to 0.44439, or if I use inverse, sine inverse, we get B is 26.38, we'll say. I'm going to go on and store that as alpha B. Okay, approximately. And then it would follow that angle C is going to equal 180 degrees minus A minus B. Okay, so if we do that on the calculator, I've got 180 minus alpha A minus alpha B. We get 117.2, let's just say 117.3 degrees. Okay, I'm going to step back and make sure that that answer makes sense. My largest side is side C, and my largest angle is side C, or angle C. My smallest side is A, no, my smallest side is B, and my smallest angle is B. So that answer does make sense. Okay, where we have A is equal to 36.3 degrees. Oops, sorry. Okay, B is equal to 26.38, and C is equal to 117.3 0.3 degrees. Okay, but there was another possibility that comes from angle B when we use the law of sines, and we do have to consider that possibility. So again, I'll do this in a slightly different color, but we could have had an angle in quadrant 2 that has a reference of 26.38 degrees. Okay, we'll call that B prime. Of course, it's going to be 180 degrees minus 26.38, which was we stored as angle B in our calculator. So let's look at that. 180 minus alpha B. I've got 153.6. Okay, so B prime would be 153.6 degrees, but I think we already know that that doesn't make sense for two reasons. One, um, that that angle would end up being larger than angle C, and that's not going to work. Also, I believe that when we look at all of the angles together, we've got too much. We already know that A, this isn't going to change. A has to be 36.3 degrees. If I add this 153.6 degrees to that, that's already more than 180 degrees. So that's not going to make a triangle for us. So there was only one solution for this problem, and that is where we have angle A equals 36.3 degrees, B is 26.38 degrees, and C is 117.3 degrees. All right, so we have another application here. It says an airplane flies due north from Fort Myers to Sarasota, a distance of 150 miles. Okay, we can see that here in the illustration. Okay, then turns through an angle of 50 degrees and flies to Orlando. Okay, so we flew north and then we turned an angle of 50 degrees and flew on to Orlando, a distance of 100 miles. How far is it directly from Fort Myers to Orlando? Okay, so that's what we're interested in this particular problem. So we already have, we can see in the illustration, a nice triangle. And what we're looking for in this triangle is the length of this third side, which is going to be the distance from Fort Myers to Orlando. We've got the length of two sides. We have an angle that's actually on the outside of the triangle, but it'd be easy for us to figure out what this angle is just by subtracting 50 from 180 degrees. So we get 130 degrees. Okay, and we're trying to solve for D, so I can say that D squared equals 150 squared plus 100 squared minus 2 times 150 times 100 cosine of 130 degrees. Okay, we can use our calculator to find that. And we get, that's the squared value. So I'll just go ahead and take the square root of that. And I get 227.6 miles approximately. Okay, D equals 227.6 miles approximately. Okay. Now the next question is, what bearing should the pilot use to fly directly from Fort Myers to Orlando? Okay, we talked about bearings. We said that they were measured from a north-south line. So we can already look at this picture and see that, we're going to measure from the north line and we're going to go out to the east. We just need to figure out how many degrees to the east we need to go. So they're asking us to find this angle. We'll call it F for Fort Myers. And of course, we already have the length of the opposite side is 100. And then we have this pair with D that we just found and the angle 130 degrees. So I can use the law of sines here. And I'm going to say F, or rather sine F, over 100 is equal to sine 130 degrees over D, which was the 227.6, okay? Or sine F equals 100 times sine of 130 degrees over the 227.6. And so on our calculator, we'll say 100 times sine 30, or 130, divided by our previous answer, so second answer. And I get 0.366, or 0.336633. And then, of course, to find F, I need to do the inverse of that. So second sine inverse, second answer. And we get 19.67 degrees. Okay, I'm going to store that as alpha F, just in case I need it. Okay, F equals 19.67 degrees. Okay, we can consider whether or not another answer would work, but I think we can kind of look at this one and see that that's not going to work because we already had a very large angle with the 130 degrees. So if I did 180 minus the 19.67, that's going to be approximately 60 degrees for a second solution, and that 160 degrees and the 130 degrees, they're not going to be able to be in a triangle together. So my bearing then would be north 19.67 degrees east. All right, we have another problem where we're going to try to use the law of cosines and probably follow it with the law of sines. It says, in attempting to fly from Chicago to Louisville, a distance of 330 miles, a pilot inadvertently took a course that was 10 degrees in error, as indicated in the figure. Okay, so he was going from Chicago to Louisville, but instead of going along this path, he was 10 degrees off of the path. Okay. If the aircraft maintains an average speed of 220 miles per hour, and if the error in direction is discovered after 15 minutes, through what angle should the pilot turn to head toward Louisville? All right, so we're interested in trying to find the error, or rather the angle, that will correct his path after he's already been traveling for 15 minutes. Okay, so the first thing we need to do is try to figure out how far did he go. Of course, we know distance equals rate times time. And so we have a rate of 220 miles per hour. And 15 minutes is a quarter of an hour, so 0.25 hour. All right, and so we get 55 miles. Okay. All right, in 15 minutes, he went 55 miles in the wrong direction. All right, and we're trying to figure out this angle that he needs to turn through. And in order to do that, we kind of need to know this angle, which is a part of the inside of our triangle. So we've got angle 10 degrees. We've got the length of two sides. It would be easy for us to figure out this other length, okay, using the law of sines. Let's call this, we'll call it little c, since it's opposite Chicago. So I can say c squared equals 330 squared plus 55 squared minus 2 times 330 times 55 cosine 10 degrees. Okay, we'll do that on the calculator. Okay, I got that, but I need to take the square root of it. So I think I made an error using my big giant calculator. Let's see, I did 3,330 miles. That was too much. Okay, let's go back. Okay, let's take out one of those threes. Okay. All right, I got that, and if I take the square root of that, we get 276. That makes a little more sense. All right, so the length of side C is approximately 276. Okay. All right, but I'm still trying to figure out this angle. And I think now that I've done that, we will need that 276 to answer part B, but I don't know we need it to finish answering part A, but that's okay, we've got it now. So let's call this, we'll just call this X, capital X, okay? So then I can use the law of sines and say sine X over 330 equals sine of 10 degrees over that 276. I do need that now. Okay. Or sine X equals 330 sine 10 degrees over 276. Okay, 330 times sine 10 degrees divided by alpha C. I've got an extra 3 again. Okay, I get 0.207. And of course, I want to really know what X is, so I'll go ahead and do sine inverse. And I get 11.98. Okay, so X equals 11.98 degrees approximately. But remember that there are two answers, okay? And looking at our picture, it doesn't make sense since our largest side is 330 miles. It doesn't make sense that the angle on the inside of that triangle would be 11.98 degrees. And I think we can also kind of see that clearly the picture is not drawn the scale. If this distance from here to here is 55 miles and all of this is 330 miles. So what we'll have to say then is that the angle on the inside, we'll call it, I guess, x prime, the thing that works is going to be 180 degrees minus this 11.98 number. Okay, that's the piece that we get on the inside. However, what we really wanted in this case was the angle that's on the outside. And I'll go back to the picture in just a second. Okay, that inside angle has to be 168 degrees. Okay, but like I said, we really wanted to figure out how far does the pilot need to turn to correct the path. And so once we found that this was 168 degrees, we do need to subtract that from 180 to figure out what this angle is. So for the question that's asked, it turns out that the correct answer is 11.98 degrees. Okay, so to correct the error, the pilot needs to turn 11.98 degrees. Okay. How far, or it says what new speed should the pilot maintain so that the total time of the trip is 90 minutes? Well, we've already lost 15 minutes, so we're down to 75 minutes, and we still have to cover 276 miles. So we want to know the speed. We can say R equals D over T, or the 276 divided by 1.25 hours. Okay, 75 minutes is equal to 1.25 hours. And so if we do that on our calculator, 276 divided by 1.25, I get a speed of 220.8 miles per hour. All right. All right, we have another example. This one is for a radio tower and some guy wires that hold or support the tower. It says a radio tower 500 feet high is located on the side of a hill with an inclination to the horizontal of 5 degrees. How long should two guy wires be if they are to connect to the top of the tower and be secured at 2 points 100 feet directly above and directly below the base of the tower? Okay, so I think you can see the illustration here, and we've got the tower, which is still going straight up and perpendicular to the horizontal. And so we need to figure out the measure of some angles here. Okay. So this doesn't turn out to be, of course, a right triangle. We've got this, and so we've subtracted off 5 degrees from this inside angle, and so we get a measure of 85 degrees here. All right. The distance from the tower to the wire is 100 feet, And what we're trying to figure out is the length, we'll call it X, of this guy wire. So we have an angle. We've got the length of one side, and don't forget we have the height at which the wire is attached to the tower. That's 500 feet. Okay, so we've got 500 feet right here. So I've got the scenario of side, angle, side. And so I can say x squared equals 500 squared plus 100 squared minus 2 times 500 times 100 cosine of 85 degrees. Or it would be the square root of 500 squared plus 100 squared minus 2 times 500 times 100 cosine 85 degrees. And we get 501.28. I think our units are feet. Okay, x equals 501.28 feet. Okay. On the other side, instead of subtracting the 5 degrees, we're actually going to gain that 5 degrees. So this angle right here is going to be 95 degrees. We still have a length of 100 feet, and the wire is still attached at a height of 500 feet. So let's say I call this one D. We get that D squared is equal to 500 squared plus 100 squared minus 2 times 500 times 100 cosine of 95 degrees. Okay, so I'll just use what we typed in last and change that 85 to 95. And so we get 518.38. Okay. Now let's look at some other applications of triangles involving area. Of course, you probably are already familiar with the area formula. A equals 1/2 base times height. But sometimes it's difficult for us to figure out what the base and height are, especially if they're not equal to the length of one of the sides. So there are some other formulas, and I should mention that often K is used to represent the area of um, a triangle. I'm not sure why, but if you see where K is written like it really was here in the notes, then it does represent the area. Okay. We can also find the area of a triangle by saying 1/2 AC sine B. Of course, write that in terms of the other sides as well. The final formula for the area of the triangle that we will consider is called Heron's formula. And it says that the area is equal to the square root of S times S minus A times S minus B times S minus C. Okay, where S is what's called the semi-perimeter. So it's half of the perimeter of the triangle. So it's going to be 1/2 of A plus B plus C, where A, B, and C are the lengths of the sides of the triangle. So depending on which information we're given, we can choose the most efficient formula to help us find the area of the triangle. All right, so let's find the area of each of these triangles. First triangle, we've got sides A and C, and we've got angle B between them. So I can say area is equal to 1/2 AC times sine B, or 1/2 times 2 times 1 times sine of 10 degrees. Okay, so the area is going to be sine 10 degrees. We get 0.1736. All right, in B, we've got angle A, and we've got two sides, B and C. A's between these two sides. So again, we'll say area equals 1/2 BC sine A, or 1/2 4, 1/2 times 4 times 1 times sine of 120 degrees. So we got 2 times sine of 120, and I get 1.73. And these would be, since we're talking about area, this would be units squared. Okay, up here as well, we would have whatever the units are squared. All right, in C, since I have the length of 3 sides, then I'm going to use Heron's formula. And so the first thing I want to do is find that semi-perimeter. So S equals 1/2 of 4 plus 3 plus 6, or 1/2 of 13.5, which is 6.5. Okay. Now I can find the area by looking at the square root of 6.5 times 6.5 minus 4 is going to give me 2.5. 6.5 minus 3 is 3.5. And 6.5 minus 6 is 0.5. Okay, I want to take the square root of all of that. And I get 5.33. Yep. And again, this would be in units squared. Okay, so let's see if we can take a look at an application. It says the Bermuda Triangle is roughly defined by Hamilton, Bermuda, San Juan, Puerto Rico, and Fort Lauderdale, Florida. The distances from Hamilton to Fort Lauderdale to San Juan, and San Juan to Hamilton are approximately 1,028, 1,046, and 965 miles, respectively. Ignoring the curvature of Earth, approximate the area of the Bermuda Triangle. So in this example, we've got the length or the lengths of three sides of this triangle, and we're trying to find the area. So we're going to use Heron's formula. Okay, of course, we know what the formula looks like already. It's the square root of s times s minus a times s minus b times s minus c. Okay, so I need to know what that semi-perimeter is. Don't forget that s represents the semi-perimeter. Okay, and so we get 1/2 of 1,028 plus 1,046 plus 965. Okay, multiply that by 0.5. All right, and I'm going to store that in my calculator as S. So store alpha, and it doesn't matter really what I store it as, but I'll store it as alpha S. And then I'm going to use that instead of typing this all out or typing that number over and over again. I'm going to use alpha S in my calculations. And so I get the square root of alpha S times, and I don't have to use the time symbol, 1,028 minus alpha S and I'm sorry, I should flip that around. It should be S minus 1,028. So let me go back. Then we've got S minus 1,046 and S minus 965. Okay, and I get 442,815 square miles. Okay, when we plug into the area formula. 815, we'll just round it, approximately this many miles squared.